Thanks, everyone. This is currently Managing Asynchronous Workers. We have a lot of stuff to cover. I typically use an hour, we have 15 minutes, and I'm 2 minutes behind already. So we'll go ahead and just jump right into it. I'm Justin, the Director of Engineering at Desert Digital Media. I'm also the Utah Community Music Group President. I basically make and break web stuff. I've been doing this for about 10 years. And if you want to get a hold of me on Twitter, I'm at Justin Carmony, and then Justin Carmony.com to get a hold of me personally. I always love to answer questions. So even if like 2 weeks on the road, you're doing something like, Justin, talk about this. Feel free to shoot me an email. Slides are posted online. They'll be on the joined in web page for Speed PHP. Feel free to ask questions on the topic. Given how short time it is, I might have to skip you, but feel free to ask them and I'll not skip. We can do a Q&A session at the end or afterwards at the conference, or you can contact me whenever. All right, so we're going to talk about the theory of workers and then why they can be kind of difficult to manage. And this is programmatic, not humans, even though that could be a whole other talk, but pretty much all the valid same points. And we're going to talk about how you best practice for writing them and then handling the hiccups when you have them with workers. So let's start with a story. You work for an office tech company. Your team is working hard to build cool new things, and your team gets called to work over the Death Star. And apparently Darth Vader said, I have a really cool idea. I have a lot of stormtroopers who need to find things, and it's probably, I can't do Darth Vader, of course, I'm not going to try one. But I need to make Darth list, where people can go in there and post classified listings for like blasters or droids or whatever it is on Death Star. That way when you have stormtroopers looking for some droids, they can go online and be like, hey, I need to find some droids. Then we may find the right ones. And so you're like, awesome team, you're off. And then you get some stormtroopers using them. And then some more, and then some more. You get this huge user base, lots and lots of people using them. Well, then one day your boss calls up and he's like, hey, I need you to add email and push notifications by tomorrow, or else I'll force you or something. And so collectively as a team, you think the same thing as everyone else, and you say, all right, let's go ahead and drink some Red Bull and get to work. And so you get this post a listing page and put the title and the description. You can probably upload emails or upload pictures and whatnot. And I have this logic of like, okay, we submit it, I'm going to get the data from the post variable, I'm going to validate it, we all do that. I'm going to save it to the database, and then I'll send an email to anyone who has the subscription for Droid, or whatever the keywords are, and then render a success page. And so as a developer, you're like, I'm sure this works, and you push it to production, and you go to bed. You call your boss and say, hey, we're all good, you can relax, the feature has been shipped. Who does this sound familiar to? Maybe it's a personal experience. Anyway, so the developers would crash because they are exhausted, and in the morning, emails start going out, and they realize that, wait a second, there's a lot of these things. Apparently a lot of stormtroopers looking for droids. And then the ops team calls up, hey, our servers are melting, there's a big crash and things burn, there's a big cleanup effort, your boss gets burned, he's not very happy with you, your coworkers make fun of you, and it makes for a very sad developer. Now, these things happen to all of us. I may or may not have had this specifically happen to me, maybe not on the Death Star, but really similar things. And so what the question is, what happened? What did I do wrong? And so I look at this page, and I look at programming logic. I'm like, all right, get the data, validate, save the database. And I send emails to subscribers. And I start thinking through, and I'm like, wait, that's more that list. I break it out, it looks more like this, and there's some more users, and then I render a success page. And during that big chunk of work is when things time out, and people are like, oh, I don't know, did it submit? And they submit some more, and hit 5, and life is just wonderful. And so it takes a long, long time. And so instead, the idea is, okay, instead of doing this complicated work, whether that's sending an email, whether that's crunching a report, whether anything that takes some time, that's longer than the user can wait for, which is like 200 milliseconds, we need to not do that right then. We need to go ahead and queue that for doing the future, and then render the success page, and then send those jobs asynchronously. So that brings us to the wonderful theory of workers. And in theory, as all things, most of the time it's pretty simple. I have a job, I put it in the queue, a worker takes the job from the queue, it does the job, and repeat. And so it's this nice, beautiful flow chart, job, queue, worker, and we're done. And that's simple, right? But at the end of my talk, we're good to go, that was worth your time. Right? Well, in our minds, I think it looks like this. Ah, it's this beautiful machine, and it goes and it took me forever to find a video of this. You know, paste like whatever these pancakes or industry waffles, whatever they are. But the reality is sometimes it more looks like this. We automated everything, and this happened, and now I don't know if I'll ever eat a cup of soup, a noodles, whatever those things are called. Every one of those again. And so the reality is when you automate things to do things in the background where you're not paying attention, it can actually get kind of complicated and complex. When you're not looking, these seem to break and do weird stuff. And so the reason why is that in PHP, normally a web server, it runs for milliseconds. You know, 5,000 milliseconds, 5 seconds is a long time. Whereas for these workers, they might run for hours. And then a lot of times you have connections that have timeouts, because typically I don't want my web page to wait for an hour to the database, but in a server environment, they're like, no, it's totally normal for it to have an hour-long connection to the database. And then how do I keep these stupid things running? Websites, they have Apache or Nginx and FPM. They take care of all for me, but now I'm in charge of that. How do I actually do that? You know, and if I need to restart it, you know, or if something dies, Apache magically will spawn a new thing. That's just fine, but now I'm in charge of that logic. And then monitoring it, you know. It's really hard. When a user can't get to the website, it's easy for them to be able to tell, hey, I'm getting 1 page or I'm getting 500. But like, there's like, I didn't get my report. I don't know what happened. And so there's a lot of monitoring I have to do for that. And sometimes it can even be a little dangerous. You know, like, oh, my worker filled the disk, filled the entire disk with temp files. Or we accidentally reran that refund job 1,000 times. And so that $50 thing now became $50,000, and that person is really happy, and my boss isn't. So workers can be complicated things to do. So we're first going to talk about some of the best practices, I think, for writing code that runs asynchronously and managing those jobs and keeping an eye on them. Or how not to hate your life. So my first thing is try to keep it as simple as possible. The more complicated your jobs get, the more complicated the steps get, the tools, whatever, and you're harder to debug. So if you can keep it simple, that's like the best strategy to start off with. The second thing is use the correct tools for the job. As web developers, we're normally not used to running long-running services that don't render HTML, but they talk to things and whatnot. That's kind of outside, so sometimes we might use tools that we're normally using for websites in an inappropriate way, and there's a better tool for the job. So the first thing you're going to need to do this is a queue. Now in the port queues, I've done all of these and regretted it. I've used my relational database, and there might be a time where that's important, like a transaction, okay? But you know, logging something or sending an email. If I'm sending 1 million emails, I don't have to read and write 1,000 times the database and update that or whatever. Or I've seen people use flat files like, oh, all right, this being a cron job, we'll check to see this directory and scan for files, and you know, there's better things out there. You have things like Beanstalk, RabbitMQ, Redis, Gearman, and then Amazon SQS, IronMQ. There's lots of different services out there. My recommendation is Beanstalk to start with. It's lightweight, it's fast, and it's simple. And the reason that is that by default it's in memory, so you're typically not going to run through in throughput issues. It's also dynamic. I don't have to go set anything up at the beginning and find I have 20 job queues and they do these things. It's all dynamic on the fly. But it also has a handful of nice features. For example, if you have a job that's an error, you can bury that job, is the term we use, and I'll put it into this special buried state. It won't rerun the job. That way you can go and look and say, hey, I have these 10 jobs that failed to run. I'm going to go investigate why that happened. And then when you fix the problem, like all the email servers back online, you know, you can then go keep those jobs back into production and they'll run. The nice thing too is that if you have a random issue where a job isn't finished, you can set a timeout, say, hey, if this job doesn't report back as being done in a minute, we'll put it back in the queue. And then if you outgrow it, the tool, you can always go move to something else. This is a great starting point for most use cases. So our code examples, we're using PHP 6, we're using Beanstalk for our queue. We'll use Redis, which is like an in-memory key value store for status information. And then the library we'll use to talk to Beanstalk is called Beanstalk. And then, lo and behold, the library we'll use to talk to Redis is called Redis. So the typical life cycle is the client or the website, whatever, will go and put a job in, and then this worker will reserve that job, and then once that job has been completed, you say, oh, that's done, I can now delete the job. If you want to use some of the bury and kick stuff or the delayed things, the life cycle can get a little more complicated, but still pretty relatively really good. You can say, hey, put this job in, but I'm going to give it 10 seconds to make sure replication is kicked in for all our slaves, and then have it go ready, and then a worker reserves it, and then if there's a problem, it can go bury it, which then you can kick in. You know, I have this site online, you can go look at this. But there's a couple of nice features in Beanstalk that let you handle regular job workflows. So queuing the job. With Beanstalk, you store a string, and manipulating strings is all great and nice, but I like having a little more structure on my data. And so I have to have a JSON object representing my job. And I'll do things like I'll say, okay, my job, my title is send an email. And then I'll have data, and I want to send this to this person, from this person. Have this subject line, have this body. And then maybe if I want some reporting back of what happened, I can have a callback, I can call for success, or maybe an error, And this isn't hard-coded into Beanstalk, just whatever you want to put, however you want to structure your application. You may or may not need all these things. But we have the data for that specific job, those callbacks. And then you give a name to a queue. And in Beanstalk, they call them a two, but everyone just calls them queues anyway. So just queue or two can mean the same thing. One thing I recommend is only put similar jobs in a queue. I don't want to have my refund, a really important thing, in the same queue as run that super duper long complex report for some CEO in that same queue and have it get clogged up with a million of those. So put similar jobs, like if I'm sending an email on an email queue. If I have a report queue, I'm going to have a report I want to generate, I'll have a report queue. You can't use priorities. I don't like to personally use them. I like to have different queues and then just have a policy. First thing that goes in, the first thing that goes out. And then workers can listen to multiple tubes. So you can, in Beanstalk, you can say, oh, I want to listen to these 5 tubes. And then you can do these tubes that are priorities. And then you can have dedicated workers for a particular queue. So let's say I have my email server, I have 10 workers that listen to all my priorities, and then I have 2 workers that's just on my highest priority. That way when I click the email reset, link, and the marketing person before me sent out 1 million emails to 1 million people who didn't want them, I don't have to wait for those 1 million emails to be delivered before mine gets sent. So that's kind of some best practice for linear queues. So we might have like an email.priority or underscore or dash, however you want to call it. And so priority I might use for like password resets. I might have a regular thing for saying, hey, that your friend, liked your picture, cool. And then for the bulk stuff that we'll just go up to staff anyway, but you can have it for that. And then when you in Beanstalk, when you queue it, there's basically 4 things you pass to it. You tell it, here's the data, here's the priority, the number of seconds that I want to wait for the job becomes available to be pulled by a worker, and then the time to run, or how long that job can go before the worker doesn't report back saying, I'm still working on this, or it's done, I'll re-put that job back into the queue. And then it's always better to be explicit. There's default values, but it's just much better to say specifically 0-second delay. We can run a minute, 60 seconds, and go from there. So let's say we're going to go ahead and code up our code that handles this. We'll create our job object, have the constructor, I can pass that information in. And then if I want to go send that job, or send a job to the queue, I connect to Beanstalk through Beanstalk. I set my data, I go and create that job, and then I'll go and code that object. Or maybe I'll have that object have a 2JSON function on it that will then pass that information to Beanstalk. So right here, create the job, and I tell it, I want to put this in the email regular queue, and here's my data. My data, weight, 500 milliseconds, or the priority. There's priority 500, don't wait, and it has 2 minutes to run. So now that I got the job in there, that's the easy part. Now I need to go write the code that will listen for jobs and process them. And so once again, there are better tools than others. I've done some of these poor ways. I've curled a web request via a cron job that would like wait, trying to run the request for like 5 minutes, and Apache would hate me. It always broke all the time. Or I could just quickly code up a random one-off script that doesn't live in source code control, it doesn't use any best practices. There's a lot of poor ways to do it, or there's better ways. Make sure you run your workers from the command line. Go use Bootstrap and auto-load code. Many times I'll think, I'll just really quickly write this one off the script, and then of course I'll have to maintain it, and then I'll hate myself in 3 months when it's become a giant, long piece of crap. There's a top thing called block listening. You can pass arguments, and you want to build your worker to be able to run multiple workers on the same server if you like. Starting from the command line, there's no complexity of web server. You don't have to worry about timeouts. And then it's easier to keep running, and it's easier to manage logs and monitor listings. One most common problem is older versions of PHP or configurations will have timeouts set. Most, though, modern distros and whatnot will have the timeouts set to 0 if you're in the command line. But it's just something to keep in mind. Bootstrap and auto-loaded, the worker code should feel like it's part of your application, not this weird one-off script off to the side. And I've seen a couple heads nod because everyone knows exactly we've all done it. But no, let's treat it like part of our application. The code, that PHP file that you actually execute should be minimal in and of itself. It should just go create an instance of a worker and then run it. And then go ahead and write tests for it. Use object-oriented programming. You'll love yourselves in 3 months when you have to go maintain it. When someone's like, hey, I need this one small tweak made, and you're like, I want to go be able to easily maintain the thing. So treat it like it's part of your application code. And use coding best practices. I'm serious. So, of course, I don't take my own advice. Here's a bad example. I actually wrote this like 1.5 years ago. And like, I required, Matt, my coworker, is laughing because he's seen this in production. He's had tried to debug this thing in production, and he's just like, what was Justin doing? So I have like this weird, like I'm requiring the settings. Let's go back real quick. And then I define this function, inline procedurally, and how I can echo to the command line. I have this weird PID file thing that I'm like defining, and if it doesn't exist, like all this complicated logic, in line, and it just keeps going and going. And I think this, literally, this script, which technically is still running in production, is maybe like 800 lines, and it's awful to maintain. It is awful, and that's why every time there's a bug, I have to fix it because I am a bad boss. A better example would be, hey, like I'm using namespaces, and I say, hey, I have this worker factory, or whatever, something to go and create the settings and inject them and whatever. And then I have my email worker that I use. That probably extends a worker class or something. And then I use auto-loading because we all use Composer here. Yes, hopefully, if not, we're looking into it. It makes our lives so much easier. And then we have this Bootstrap file that's probably identical to the way we used it for the web. It's like, hey, here's how I bootstrap my application, and this is going to run the command line instead of the web. And then I come down here, and I create my new email worker. I'll insert my dependencies, in the constructor, and then eventually I call run. And it's really simple and clean, and then Matt, my coworker, knows he can go to the class email worker and see what the heck is going on. And hopefully there's not 100 lines of procedural code. All right, so when you create your worker, there's a couple of things you want to set up before you actually have it start running. Here's a mention of the time limits. You normally have to worry about this in modern distros, but once again, if you want to, you can set time limit to 0, and that way, in 60 seconds or 5 minutes or whatever, PHP won't, exit saying I've ran too long. Because it's a worker, we're expecting it to run long. And then setting up your worker. I recommend, whenever I create a worker, creating 2 IDs or 2 strings. I'll have a worker ID that's unique for that worker, so I might include, this is running on server 1, and this is image worker 2. And I'll have an instance hash, and I'll generate that randomly on the fly. That way, when it runs the first time, it has this unique hash, and then when I reboot it, it has a new hash. And I can use that hash to debug and say, hey, the hash has changed 500 times in the last minute. Maybe my workers have a problem and it keeps restarting itself. And then I'll do something like this. have my constructor, I pass in the worker ID to it, and then I generate a unique MD5. Because it's a non-secure issue, it's okay to use MD5. If this was passwords, I would be shocked. But for just random string for help or functions, it's fine. Okay, if there's the #1 problem people run into when doing workers, is the connections die. For example, on the website, I don't want my web page, if you can't connect to the database, to wait 10 minutes before coming back saying, my bad, that didn't work. However, these connections, or if I have a query that runs 10 minutes, and the user doesn't want to sleep, it's never going to finish, I want it to come back with that error sooner. However, in the worker, that's a little bit different. So there's timeouts typically for these connections that you want to have different for your application. One thing I like to do is I like to ping the connection before I start a job. So before I start my complicated query and logic, whatever, I say, hey, am I still connected to the database? And if my connection is not, go try to reconnect. If I fail to reconnect, I'll throw an error and log it. Or, okay, cool, I reconnected, let me go do my job. And then if you have infrequent jobs that run just occasionally, just go ahead at the beginning and create all your connections. At the end, turn them all off. And your life will be much simpler. All right, getting the jobs from the queue. There's the poor man's way of doing it, which is called polling. And that involves, let's say I have my queue, and I say, hey, get my job. And then I check to see if the job exists. I'm like, oh, cool, I'll do this job. And if not, it didn't all the way down. There is a sleep for 5 seconds. The code is about right here. I'll do a sleep and wait 5 seconds. You know? But what happens if I check for a job and immediately afterwards, someone sends that job saying, hey, I have a job for you. You're going to have to wait that 5 seconds. And maybe your developer put a minute because he wasn't really thinking that you have a user waiting for their password set for a minute, which we all know is really frustrating. I'm like, come on. I spent a lot of money. I joined in until you got a message. Or LinkedIn. A better way is blocking. And what this does is, and Feedstock supports this, is I'll go ahead and have my worker, when I run, I'll go ahead and get my Feedstock instance. I will say ignore, by default, you listen to the default queue. So I never like to do this, so I always ignore it. But I say, hey, watch these 3 queues, and then while run is set to true, so while I still want to run, I want to say I want to get a job and reserve it, and then I pass in this timeout. And what this says is, go ahead and listen for a job, and if one's not available, wait. Keep the connection open to the Feedstock, it doesn't take up any CPU, doesn't do anything, but I'll wait up for 5 minutes. And then, the instant, the nanosecond that a job comes in, Feedstock can say, there's a job ready. And if you use jobs a lot in your application, this makes it feel very responsive, very snappy, very fast. Let's see. Yeah, apparently my slides are having a problem all the way down. So I apologize. Okay, actually doing the work. Here's a poor example where I have, like, I get my job, that's fine. I decode the data, and then I have this if statement, and then I have another if statement, and then another if statement, and once again, it starts to look like very procedural code. One thing I prefer to do is to go ahead and have the function that's like, oh, process job. I get a job, and I go to process it. And then it will go, and then once if it succeeds, I'll go ahead and remove the job from the queue. Yeah, and then inside that process job, I'll have like maybe a list of available jobs. Send an email, whatever, and all those jobs have the same interface. And I can say, hey, if this job's one of my available jobs, go ahead and pass it in. And because they all have the same interface, I know how to interact with them, and I don't need a giant 50-line if-then statement or a switch. Yeah. So I go ahead and I create my new job class, and I call process, and I return the result if it's successful or not. So it's just simple little things that make your life a lot easier. Logging. Yes?
So can you also run multi-parallel processes and access the same queue?
Yes. So what you would do is, and I'll talk more about this later, but what you would do is you run multiple instances of workers. So each worker would only work on one job at a time, but that you could run 5 or 10 or 500 across 20 different servers, and they only worry about themselves, but you can run as many as you'd like.
But how does it work? Like it takes one entry in the queue basically, so
yeah,
it logs it?
Yeah. So grab that one job from the queue, and no one else can grab it. You reserve that job, and no one else will touch it unless the time expires for your time to complete that job, and then it'll put that job back in the queue. And that timeout should be plenty of time for the job to complete its work, and then that's only happening if the worker had a weird fatal error or something.
But that timeout doesn't block the queue. Another worker can grab something out of there.
Yeah, another worker can grab things out of there. For logging, just use monologue. That's all about this. It's has everything you need. It's really easy. It's different logging levels. And the cool thing is you can log out different things. I could have a stream handler that writes up to a file and it logs all my debug information. And I could log rotate that and delete it every day or whatever. But if I have I could push to my Redis handler server, say, hey, whenever there's an incident happens, push add a string level to this set, and I can say do that for my error level or my critical level. And that way I can have a small log when I have really critical problems that are happening. And then I would go in and pass this logger to my worker, and then my worker could go ahead and use that logger class to do all this logging. And instead of echoing out everything to the family, which is done in the past, and then it becomes really hard to use. So, for example, where's the job? And, hey, I found my job. I process the job. And I come down and say, hey, I finished the job, I'm deleting it. And that's all the debug level. And if I were to have an error, I say, hey, I'm going to log this as a warning. Say, hey, that job failed. I'm going to bury the job. Something else can go and clean it up. You can do different logging handlers for different levels. So you might have a standard error, standard out that goes to a file. You can log notices, email, and maybe get a critical issue. So if your job that goes in and does payroll fails, you can email yourself saying, hey, you're not going to get paid tomorrow. Hurry, go fix this so you can have a fun weekend. Whatever that may be. Okay, reporting status. The general concept is I want to be able to have this worker because once again, it's not a user who's looking at a website. It's this bit of code that's running off to the side of a different server. I want it to be able to tell me, hey, how it's doing. This is really important for your debugging and monitoring. So things you want to report to is the current runtime. So hey, I've been live so my worker is running for 2 hours. My last heartbeat was 5 seconds ago. I am currently idle, or I am currently running job 1, 2, 3, 4. And maybe here's the number of jobs I've done, and here are the number of errors I've occurred. Just some simple things. You don't have to do this, but just some things I've found useful in the past. And then you want to have some type of storage. Use something that can take high volume read to write, so you don't have to worry about performance issues. Use Redis, that's my recommendation, or something like it. And don't do what I've done in the past and use like a primary database to store all my status information, which then gets replicated, which makes me realize that I can't use replication because my binary log grows by 50 gigs every day. That was a really bad idea. Just go ahead and learn from my mistake and just use start with Redis. It makes your life much happier. And when you report a heartbeat, lots of things do heartbeats, whatever, basically saying, hey, I'm still running, I'm still alive. Because once again, when it dies, I don't have a web person or a web page who's like, what's wrong? It just happens in the background. And then typically I like to report a heartbeat when it's idle or before, during, or after a job. So basically, anytime it would be convenient to say, hey, I'm still alive, I fire off a heartbeat. Not heartbeat code might look something like this. You know, hey, heartbeat, I'm currently idle. I'm going to just wait for a job. I get a job, and it's decode that job and say, hey, heartbeat, I'm processing job. Maybe I have some job ID or some data associated or a stream name, so this is that processing job, send an email. And then I try and do that job. Then after I go ahead for success, I delete the job, whatnot. And at the very bottom, didn't come through. At the very bottom, I promise it says, I finished this job. All right, and then the actual heartbeat function might look something simple like this: get the current timestamp, the status, my worker ID, and my instance, and then how many jobs I've done, how many errors I've had, and then I have my apprentice client, which connects to Redis, and I just set a value. Hey, this is my worker ID. Here's all my data. And then somewhere else, you can program a script that says, hey, what's the status of my workers? It pulls that information to list on the web page. Really, really simple.
So what if a job fails?
So if a job fails, hopefully your code will throw like an exception or whatever. And then what I would do is to catch an exception, log that exception, and then put that job as bury the job. And that way it sits in a separate queue off to the side. It's like, I have this queue and I have a buried status. And I'm like, oh, I have 50 jobs in here that are buried. And then maybe you have an alerting tool like Nautilus or something that says, hey, this queue has over 50 buried jobs. You probably should take a look at it. But the nice thing is, let's say your email server goes down, you queue up all those buried jobs of all those emails that should have gone out and didn't. But then when you fix it, you're like, oh, good. You know, I can just put all those jobs back into the queue, and people can get their emails.
So architecturally, your heartbeat's kind of going into Redis as a database, and then something else is going to pull that as
where I work, I have like a little status page, like my local machine, and I'm like, hey, what's going on? Or it's just something internal tool that you could use that you can go check. And that it doesn't have to be pretty, it's super easy and lightweight. Okay, one tricky thing is how to, now that I got the thing running, I want to say, hey, stop. Like, I don't want you to do anything more. Or I've pushed out some new code to deployment, I need you to stop running so you can reload the new code. So, for a little bit of everything, please just don't exit or die in the middle of your script. It makes it hard to testing, it makes it hard to debug, whatever. I personally like to have a worker run status. By default, it's true, and whenever I want the worker to stop, I set it false. It allows you to go clean up connections, log events, say, hey, I'm turning off, I'm turning it down, update statuses, whatever. It just makes maintaining things so much easier. And so here'd be an example. I have while this run is true, I do my work, and then if I get an exception, let's say in this use case, I want my worker to exit and restart on exceptions. I set this run to false, and then the next loop round, it'll go ahead and catch that false. And then below here, I could have some cleanup code, like close my connections, report a status, and an email saying, hey, I'm terminating, and have it be all good. Okay, keeping the workers running. On the website, we typically have Apache use for us, or Nginx or FPM. I personally recommend a tool called Supervisor. It's a Linux-based tool. It's really, really easy to install. And it will sit there and watch a process that it controls. And when it exits, it'll just rerun that command and start it again, like near instantaneous. And then you can configure it, say, hey, restart up to 5 times, but if it exits 5 times within 5 seconds, go ahead and don't try and restart it. Send an alert and have a smart, intelligent human come figure out what's going on. And then you can configure it to go and run, hopefully, smart, intelligent. That's not guaranteed. And then you can have it configured to run both at once. So here's an example. I say, hey, here's my PHP and the path to my worker. And I pass it, I want to use the process number. And then I define the process name. And then I define the log level, the logs. So each process would have its own log. And I say, hey, redirect my errors to the log file. And then max amount of data for the log file, yada, yada. And then I want to say, I want to have 10 of these running. So that's the number of procs. And I want that integer to start with 0. So I would have workers 0 through 9. And then auto starts at the true, auto restarts at the true. And there's another parameter you can pass saying max number of retries 5 or 10. And you can say the window of time that those can happen. And so this is nice. That way you can have your workers run. And sometimes your PHP code might be super efficient and it might grow in memory. And so you can configure your worker, say, hey, after an hour, exit, and the supervisor will immediately restart it, and then I have a fresh worker running without memory issue. Even though PHP's got a lot better at memory management, it's mostly your own personal code of like, oh, I have an array of everything I've ever done. I may or may not have ever done that. Okay, telling your workers to restart or shut down. I prefer to use a DevOps tool like Salt or Ansible to give a command to the server to tell the supervisor stop these workers. If you don't have access to that, an alternate solution that I've used in the past is have a worker version that's stored in Redis. And every time the worker does a job, after it does the job, it checks that worker version. And so if the worker version is 10, it does a job, it's running a report. I've done a deploy. My deploy script increments that value to 11. It checks again. It's like, oh, my worker version is 10. The current worker version is 11. I'm going to set run defaults. I'm going to exit, and then I can go ahead and restart.
Can you dynamically scale the number of workers that you have?
You could.
Some resources that you have.
Yeah, so you could do that, you would probably want to look at like Salt or something, some automation tool or Ansible or something else to manage that. There's other AWS things that I don't personally that you probably do that. But that's probably because you've basically made your workers kind of dumb, only worry about themselves, you don't mess with their neighbors, it makes it really easy to do that kind of scaling. That's a lot of information. Okay, a couple more things, I promise, and we'll be done. Handling the hiccups. One of the big issues that most people when we first get into this is running into permissions. So please, whatever you do, even though I'd be tempted, do not run your workers as user root. It's a security issue. I personally will typically run them as the same web user if it's non-security issue. If I'm sending emails, that's fine. Or if I'm really disciplined, I can create like a worker-data user and have a separate user for that. One caveat is if you have separate users, you don't want them to share cache permissions, like the same cache directory, because then if you one worker writes a file, a cache entry, and then another worker with a different permission group tries to read that, or your website tries to read that, and it's like, hey, I can't update this cache entry. If you don't have access to write this file, I'm going to throw an error. That's just one caveat to keep in mind is just your cache permissions, because I've gotten bitten by that many times. Also, threading. Threading is awesome if you like to have bugs and have it taken on your servers and be a pain to track down. You're welcome to do it. I'm not smart enough to do threading, I will admit. And so my personal opinion is that over time, it's just way more complex than the performance gains you get by doing some cool threading thing. We may have had a junior developer who wrote a cool threading thing and it took down all of so that just may or may not have happened once. It was really cool and clever, but he had one bug and it took everything out. So I don't recommend doing that. Instead, I recommend maintaining a pool of workers, like I mentioned before. That's easy to maintain, that's easy to scale. When your worker's idle, it's not going to be using, unless you're doing something weird, it shouldn't use on hardly any resources at all. It's very predictable. So I might have a separate server and say, hey, this is going to run 10 more workers, and then all of a sudden, I get like a billion more new users. I'm super excited, and just put down the money, get another server, and spin up 10 more workers. I'll set the servers. I highly recommend that. That way, if your workers have an issue, you don't take them out of the website, or if there's a huge flood of traffic to the website, your workers are getting taken down. I can put them on separate servers when possible. And then confirming the execution of jobs. This is the question I get asked a lot. Do I have this? If the job, if it's okay that if it falls through the crack, like sending out a bulk email, okay, in the world, if I have a job that does payroll, my employees probably do not want that to fall through the cracks. And so what you can do is you create a record in an appropriate database. And hey, I'm creating this job. I put that insert that record, and then I do the job done. Good job, worker does, and then when the worker's done, part of this job is to go update that record. And then you can have this detailed information about what's going on. For all the emails you send, I would recommend this. Maybe if there's a crucial email, like, we're going to cancel your account because you haven't paid this email, you want to keep a record of that. And then you want to maybe have some details for that current job saying, hey, there's the current state, it's waiting, or it's running, or it's finished, and the timestamp, last time I updated it, and maybe any error details. Monitoring, I really like to use StatsD and Graphite. It's a metric monitoring tool. You can go to my blog if you want to. I have a whole blog post on that. I use Navigator for alerts. And things you want to monitor is the number of workers you're running, how many jobs that's executed, the number of alerts that are happening, if things are going down, or like timing how long things take. If I'm monitoring my workers, I say, oh, my email worker used to take 2 seconds to do the job. Now it's 20 seconds. I might have a problem with things. Final thoughts. Keep it simple. You know it doesn't sound like simple. There's a lot of kind of nice to have moving parts, but the more simple you can keep it, the more easier it is to maintain and use. Use your best practices for the sake of you in 3 months, because that way you in 3 months won't hate you from now. And then well-written workers can scale well. That way, when you have your cool startup and you have a flood of new users and things are going awesome, you're not going to have it fail well. You're going to have some pile of money, hopefully, and things can scale. Any questions? We have actually have 5 minutes for questions. Any questions at all? I know I went pretty darn quick, but I was going to be behind. But no, really? Not at all? Ed?
Can you compare, I mean, you didn't mention a lot, but we have used Gearman a fair bit, but it was also, I think, kind of, didn't really know which to pick. And
Yeah.
so I think unless you want to evaluate a set of different tools, like for 6 months each, it's kind of hard to tell.
Yep.
Can you explain a little bit, it sounds like you're still using Beanstalk in production, and have you ever been like, hey, you know what, maybe I want to switch to Gearman, or what's the pluses and minuses with it?
Okay.
I mean, I have my own pluses and minuses, but I can't compare it to anything.
Yeah. So, so the question was, do we have any majors like to a solution like Gearman versus Beanstalk? And so a couple pluses and minuses for me. And for those who don't know, Gearman is kind of more of a complete solution in the sense of it kind of like has like this library you install and the server that you run. And some of this code is already done for you. But for me in the past, when I've done a little bit of it, it's kind of this black box, kind of hard to kind of take a look and dive into like what's going on. Some of the downsides of Beanstalk is there's sometimes it's a little bit more of a black box when it comes to the queue itself. Like you'll report, I might have 10,000 jobs in that queue. I'm like, okay, cool. But there's the tools for going in there and like, what's job 4,323? It all exists. It's very much kind of an end-to-end, like I read and write from my end. And so sometimes I run into issues with that. And then if you have really important jobs that you need to audit, so like financial transactions or user account management things, or if I was running a cloud service, I'm spitting up resources and spitting them down, I want to be able to audit that very clearly for billing or whatever it could be. Other more robust tools might be more appropriate. I recommend Beanstalk to start with because most people, the things that they're doing are just they're important, but they're not critical. And it's kind of a good starting point. And then once you get a feel for how workers work, then a Gearman works really well, or a RabbitMQ, or an Amazon SQS or something like that. Yeah.
So I've used RabbitMQ quite a bit, and it's amazing how well it works when you guys set up.
Yeah. And
Incredibly scalable.
yeah, and the only problem I've had in the past is kind of the technical knowledge makes sure you set it up right. You need to have some expertise, whereas Beanstalk is like run and runs. So typically, if you're using like a Linux service, like apt get install Beanstalk, and then it's running where you use it. But if especially I know you guys do a lot of e-commerce stuff. If you're managing transactions and things like that, verifying the confirmation emails went out, RabbitMQ might be a great solution. I can't personally recommend it because I haven't really used it. I just when I went trying to play with it, it took me a while. I couldn't figure out how to get it to work right. So, any other questions?
Have you ever done any message queuing with like remote, like wide area connection stuff, or is it all just done like local network?
Okay, I actually had done the wide area network stuff. I used to work for a company where we did DVD kiosks that had cell connections back to our NOC. And in that scenario, and at that time we were using like Microsoft's uber heavy, bulky, I can't remember the name of it, but it's a queuing system. So I can't recommend the solutions, the tools to use, but the biggest thing in that case is be fault tolerance. And making sure that your jobs, like if it can't connect out, it handles that well. And I mean, that's by far going to be the biggest issue. If you have things with poor connections over a wide area network, talking to things is having good fault tolerance, and then also security. Our cell networks were highly locked down. Its internet access can only access from an IP. But if it was going over like the internet and other people could go talk to those ports and whatnot, then security is also going to be a big issue. And at that point, I would probably look at using like an HTTP API that people call and communicate with to say, hey, I need you to go create this job, and over SSL and things like that.
So similar kind of idea. I have a device that needs to pull content. I'm just wondering if there's a way to do blocking instead, because right now I just have polling. So I don't know if it would
blocking is going to be really hard because it's dependent on the concept of having a reliable internet connection.
Okay.
Your
So-
polling's probably actually
Better.
more reliable
Okay.
at a reasonable rate.
Yeah.
It's just if you had a great connection, you probably wouldn't need to poll. But in your case, I would probably say that's you're doing a good job.
Okay.
Any other questions?
What was the PHP library to access Beanstalk?
It's called Beanstalk, BH. We're all about the. That's actually a lot worse than that. We're all about the BH. We're all about the, anyway, that's. Anyway, I'll just stop there. Any other questions? All right, thank you everyone. I hope you're having a fantastic PHP. Make sure you tell your friends for next year. And then I will plug Utah PHP user group. It's uphpu.org, or you can tweet me at justcarm.com. And my website, if you want information, whatever, email me, that's great. This is the wrong budget feedback link. I forgot to update it for PHP Northwest. We're not in Manchester, unfortunately. But you can go to the PHP page and do that. So, if there's no more questions, thank you.